So a 2D list is simply just a list that has lists as its elements, right? So my list here, which I've shown in green, right? You can see the first bracket here and the second bracket there are green, right? So that's our list, and this list has 3 elements, which themselves are lists, right? We have 3 lists here, 7, 8, 9, 4, 5, 6, and 1, 2, 3. And, and so really this is one way that you can write a 2D list. It's just simply write it out with commas and put your lists in as each element that you want. Or another and better way of writing them is like this. Now this is kind of more of a JavaScript or a Java convention or kind of like a multi-line string, right? We've done these before where we set a variable equal to say triple quotes here, and then we end with triple quotes there, and everything inside becomes the multi-line string. So if you do this with a list or a dictionary or any of these set type objects, then Python will ignore all this white space that's out here, and it will look for the first element on the next line, or even on the first line. Then the comma still signifies the start of the next element, and then again, and the last one, of course, should have the trailing bracket to close off the list. So you can write your lists either way, okay? But you'll find that this is used quite often in encoding, right? You'll see them written this way because it's much cleaner, right? You can see each item, and it's just a little bit easier to see the structure of the list, right, this way. So let's say that we wanted to reference these elements. Well, we do that just like before with the correct index, right? So if we first of all, if we cut and paste this top one, or the one below, and paste it in there, then this list will be stored in my list, and then we can reference element 1 or element 0 with the right index, and that shows us the first one, 7, 8, 9. Right, of course, the same thing is true if we type 1. Oops, make sure it's square brackets. There we go. Or 2. And we can also reference it by talking about the rightmost index by -1, right? That gives us the 1, 2, 3, which is all the way to the right. So all the same references will hold true that you already use for lists, even though there are list objects as elements in this 2D list. We could also use a list to loop through and to work with each element, just as before, right? So if we typed for list in my list, for example, right? And then we type tab and type print list, right? So this list is now going to take the value of each element in my list, which has 3 lists, right? So list is going to have the first one. Then we press enter twice, and we can see we get all 3 of them printed in a row, right? Which is quite a nice way of seeing all 3 of these lists in this big list. And 2D lists are often used to represent a grid. So just imagine for a moment that this here was your numpad, right? Which has its keys laid out just like this, right? 7, 8, 9, 4, 5, 6, 1, 2, 3 on your numpad. Well, each index in the outer list, right, refers to a specific row, right? So this top one is my list 0, and then this one is 1, and this one is 2, right? So whereas each element within each inner list, right, is going to have elements 0, 1, and 2. This is how many columns there are, in a sense, right? Because these all have the same amount of numbers. So how do we reference a specific index within any of these lists? Well, here's how you do it. We simply attach a second index to the list. So let's just type for a minute. Let's type my list 0, and then we'll type index 1 after that. And you'll see it prints 8. So what's happening there? Well, recall, right, that our list is defined like this, right? So we have our first element here, first element, second, third element. Of course, their indexes are 0, 1, and 2. So, right, if we type my list 0, 1, then what's happening is it's evaluating my list 0 first, which becomes 7, 8, 9, right? Because my list 0 is 7, 8, 9. Then second, right, it's with this 1, it evaluates that second, right? So the element in position 1 of 7, 8, 9 is here, right? That's element 8. And so, so similarly, right, if we were to type my list 2, right, then this is the row number. 2 is the row number starting from 0, so 0, 1, 2. And this would be element number 2, which is the column number, 0, 1, 2. So this would give us 3 because the element at index 2 for this list is 3. Let's just test that, and we should see that it should be true. 2, 2. That gives us 3 indeed. So the real key here is that the first index in a 2D list tells us which list to look for within the outer list, right? So if we're using my list, then this one would refer to 0, 1, or 2. And the second index, the second one tells us where to look within that list, right? So index 1 within list 0, that kind of idea. Okay, so let's move on. How do we create 2D lists? Well, one way of doing it is just typing the whole thing out with all the nested lists inside the outer lists, basically like we did up here right at the beginning, right? Either of these. Or you can append lists to lists, row by row, right? So you couldn't use the append method and just keep adding lists to your outer list. And so here are the two ways of doing it, right? So I've defined 3 constants here. Poisonous things is spiders, scorpions, snakes. So it's a 3-element list of strings. Flying things, birds, bats, flying fish, and pets, dogs, rodents, cats, monkeys. So all 3 of the inner lists here have been defined. Then I've created the outer list of all the things, is what I'm calling it, all these things, by setting that equal to poisonous things, comma, flying things, comma, pets, right? So if we were to print this, we would see all 3 of these things inside the list, all the things. So if we wanted to reference, say, in this case, if we wanted to reference scorpions, well, we would say all the things, 0 to get us into the poisonous things list, and then 1 to get us to index 1. Right, which is right here. And vice versa. If we wanted to reference, say, cats, well, we'd have to say all the things 2, right, that get us to pets. This is 0, 1, 2, and then attach 0, 1, 2 again, right? So all the things 2, 2 would get us cats. You could, however, create the list this way. You could initialize the new list, all the things, to an empty list. And then you could append poisonous things, append flying things, and then append pets, and you would end up with this, the same thing. And this second way is the way, I think, for the most part, that you're going to be creating 2D lists and working with them, especially next unit when we start using them to model data and to have data structures, which are useful when making games and all kinds of things. So, let's recall one little topic here. We can create new larger lists by multiplying a smaller list. So to create a list of 10 zeros, we can do the following. 0 times 10. So I just want to show you this. So if you type in 0, that's just a 1-element list with a 0 in it, times 10. And you'll see now we have, of course, 10 zeros, right? So this expanded list returned us a new one that contained 10 of them. Here's another one, right? If we have a list A and B with A and B strings times 3, let's see what happens here. So A, comma B, if we multiply that by 3, then you'll see now we have A, B, A, B, A, B. So we have 3 sets of A, B in our list. So really, all it does is make that list bigger, right, is what it does. And we're going to use this a little bit here when we create some lists in this next example. So example 2 says, create and print a list of n rows of m zeros, where m and n are input by the user. Print the list in a grid format with spaces in between. And actually, I'll show you what it should look like right here. So we're going to take the number of rows, the number of zeros, and we're going to print 3 rows of 4 zeros, right? 1, 2, 3. And we're going to do this using a 2D list. So basically, we're going to store all these zeros in each in its own list within a larger list of 3 rows. Okay, and of course, because you don't have to do that, you could print this normally, but if they're in a list, then we can change these values, and that's the key, right? It's now a data structure that we can work with to do something. So let's start by, first of all, by defining n and m and taking some inputs, right? So we'll say n equals int input number of rows. I'm actually going to do this example a little differently than what I have displayed in this text over here on the right. So we're going to just use a basic append method, and that will avoid this little issue that we're going to see here, possibly any. We'll see. Okay, so what we need to do, of course, now is initialize our list. So we'll call this the list, the big list, and we'll set this equal to a blank list. And now we can append things to this, right? We can append lists of zeros to this. So now we need to do this n times because we have 3 rows, right? So in this case, we should go for x in range n, and this will basically take us through our loop n times. And each time we want to append the list we want to append to it a list of zeros. So let's create a list, start an open bracket, and we want to have 1 0 per m, right? Which we have read in this case is 4. So we can multiply this by 4. So now this is going to become, right? This is going to become a string of 4 zeros, right? So so this is it, right? We should now, after this is done, we should be able to see the list. And this isn't going to print exactly the way that I've required it here, but this should give us just a quick view of what should happen. So if we type in, say, 4 and 6, there you can see, right? We have 4 rows. Oh, this didn't work. We actually have 4, right? So let's change this to an m, because I should have typed m there. And we'll run that again. And of course, 4 times 6. There we go. Now we've got 6 zeros, 4 rows. But we want to print this like this, right? So pause the video here for a minute. Think of how we could print each row, right, separated by 0, so that it looks like a nice grid like this. Okay, so it's kind of staring you in the face here, right? It's line 7 and 8 for row in the list. Print, and you can use the join method, right, on each row, which is one of the inner lists that has a list of zeros. So let's try it. All right, so we delete this for row in the list, and we print, and we'll use the space as the joining character, dot join, and then the inner list object, which is row. Let's try this out. Okay, so we'll type 4 and 6. Now you notice here that we actually got an error, and I did this on purpose. So sequence item 0, expected string instance, but integer found. So in other words, when this tried to join the first element of row, notice how they're all zeros, right? And it's saying, hey, I found an integer there, but I was expecting a string. Yeah, so join can only join a list full of strings. So what do we need to do here? Well, what we need to do is append the string version of a 0. Right, and so I kind of meant to do that. See, the 0 was here as well. But let's just try this again now that we've changed this to a string, and we should be in business. 4, 6. So there we go. Right now we have a nice grid. In this case, it's 4 by 6, and it's working beautifully. So now let's just try changing some of the elements in our little list here before we print it, and see what happens. So let's change the first one. We'll change it to a 1. So we'll set the first one, which is, so obviously the outer list is the list. That's going to be row 0 and the element 0 in that one, right? We'll set this to the string 1. Now let's see if this updates. And so we'll go 4, 6. So you can see here that, right, this statement on number 8, line 8 here, actually changed that one, right? And you could go through, you could change whichever ones you want within this list, right? We could change the very last one by typing the list, and in this case, this is only gonna work, right? If I type in the last indexes here, it's gonna work if we have this size. So why don't we determine what index we need by checking how long, right, this is. And so, well, what we could do is use -1 here, right? That's going to mean the rightmost, the one to the farthest right, this guy, and then -1 again, right? So this is the rightmost, the last inner list, and the last item within that inner list. That's what that means. Set that to 1 as well. Actually, set it to 2, and let's see if this works. So again, 4, 6, yeah, right. And you can see there that we have a 2 at the end. Very cool. So before we move on here, I want to just show you one more way to make this list, which is super stylish, and that's using a generator. So we're going to skip over all this stuff here and get to this point, a generator. So let's, in order to do this, let's comment out this stuff, and we'll do it a different way. We're going to type the list, and we're going to start a generator. I want you to look closely here at what I've done, right? So, so I've used a generator, and the list of objects that are determined, right, that determine the size of this is going to be for row in range n. So remember that range n contains, right, this is going to contain n things, which happens to be the number of rows we want. So if we say for row in range n, then we're going to get n things in our list. That's all this means. Now for each one of those, right, each element is going to be a list of zeros, right? That's m in size, right? So it's 0 times m, and this should again be a string, right? Otherwise it won't print properly. So we're going to fix that ourselves. So let's do it. So we're going to have string 0, right, times m. That's what we're going to do for each row in range n. Okay, so this one line is equivalent to all this, right? Because it's going to create n rows of zeros in m in length. So let's just give this a try and make sure that this also works for 6. And there you go, you see it does. So before we go on to processing here, let's just take a moment and call this creating 2D lists. Let's call this, and then here we'll just document this using append to create a list, right? Or a 2D list, really. And this one will be using a generator. There we go. Okay. And there we go. In this case, actually this will work just the way it is because this would overwrite what was in the list, so this should be fine. All right, we're going to start with a new example here on processing 2D lists. So if you want to access each element in a 2D list, in other words, work with each thing inside each mini list, right, then we just need to loop through. And one way to do that is to use nested for loops. And so let's look at this. So processing 2D lists. And the first one is going to be looping through by index. So looping by index. All right, we'll start by assigning a list to a nested list. So we're going to have the list 1, 2, 3, 4, and then 5, 6, and then 7, 8, 9. There we go. So A is this 2D list with 3 lists in it, 4 elements, 2, and then 3. Now, in order to get through this, we can go for I in range, len A. So what is this? Well, this is going to get us, basically this is going to take us, it's going to take us through a range object of length len A. Well, this A has 3 elements, right? 1, 2, 3. So this is going to be range 3, right? For us in this case. So this is going to happen 3 times, and that's all we really want this loop for, is to happen 3 times. Then for each one of these, right, we want to go the number of times that we have things inside our mini list, right? So we can say for J, and J will take, right, J is now going to take each element in each of these lists. I will be each list, right? I will be this list, and then J in this case will be in range len. And now we want this to be the length of the object inside, right? So this is going to be A sub I, right? So in other words, if A if I is currently 0, then this A sub I would mean A of 0, which would be this list. And so the length of that is 4, right? Because there's 4 things in there. Okay. This is a little bit more complicated doing it this way, and there is a kind of a better way coming next, which I'm going to show you. So if you're lost here, don't worry about it, because on the next line, it should clear up nicely for you. Looks like we have a syntax error, missing a bracket. There we go. Okay, so now what we could do is we could print. So what we have now is we have the first index of A and the second index of A, right? So this is going to be, if we want to print a particular item, it would be A sub I sub j, right? And so a of I of j would basically get us each of these things inside. So if we want to print these kind of nicely, what we could set the end parameter to just a space, and then that way it will print them all in a line. Okay, and then after that, we of course want to have a carriage return. And what this should do now is this should kind of print out our list the same type of way as we were seeing this before. So let's give this a try, and we should see, there we go, right? It started with 1, 2, 3, 4. That's our first list. Printed those elements, right? And then 5, 6, right? Every time I restarts, and 7, 8, 9, and so forth. Let's now do this a better way, right? So, and this is the Pythonic way, looping Pythonically. So, in this case, what we're going to do, we're going to use this same list A, but we're going to use variable names and loop through each thing inside each list, right? Directly by taking those objects in the list. So this time we'll just type for row in A, right? And of course each of these is a row that we want. And so that's my choice, using row. And then for each thing we can go for elements in row, right? Because we know that the row, this is going to take each of these things one at a time, and then element will take each thing in the row, right? So maybe this makes a little more sense. And then we can just print that element, right? And again, we could make this print in a horizontal line by specifying a space at the end of each one, and then print at the end to get us to the next. As soon as we finish, right, the current row, we print a line and then go to the next. Right, so this actually should do the same thing. So comment out that, press F5, and we should see, there we go, have the exact same thing. I just want to show you this on the visualizer. Right, so I've got this pre-programmed here, and what we'll do is step through this. And so, of course, we're assigning A, and A is this big list, right, which at 0 points to another list, 1 points to 5, 6, and 2 points to 7, 8, 9. This is our outer list, and these are our inner lists. So let's loop forward, step forward here. And so now row, right, is going to be the first thing in A, and it's pointing to this one, right? So, so our first element is, of course, a 1, right? And so it's now being printed. And then we get 2, and then 3, and then 4, right? But now we've just finished each of the things in the first row, so we're going to go back. We're going to print our empty carriage return. Then we're going back to get a new row. And you can see now that row is pointing to the next thing, right? Which is here, right? And so now we're going to take, now element is going to be 5, and then 6. Each of those are getting printed. And then finally, at the end, row will point to the last one, which is the last thing in A. There it is, right? 7, 8, 9. And so we're going to see all 3 of those show up, and then we shall be finished. So that's a pretty nice way to visualize what's happening. So I just want to show you a couple alternatives to using these nested lists. Just like before, it can be a little even a little simpler. All right, so without nested loops, I meant to say loops here, of course. You can just print using your rows using join, right? So if we have for row in A, well, right, each of these, delete all this, right? Each of these row objects is going to contain the whole list you want. So if you just want to print them, you know, in a line with spaces, then why don't we just use join, right? We can type print, right, join, and then dot join, and now we have to supply the list that we want. And of course, these need to all be strings in order to use join, but we could use a little generator in here for that, right? Just convert them to strings, string n for n in row. So let's do that, all right? So strn for n in row. And of course, all that's going to do, don't forget square brackets here, by the way. Square brackets, there we go. And what that's going to do is, first of all, convert each row to a set of strings and then print them with spaces in between. So, so this should also do the trick. And then after this, I've got the ultimate version. And you might look at this and be like, what? Star? What does that mean? So what a star means is print all the things, okay, inside inside whatever this is, right? Row. And so this prints them kind of like with commas, right? So if there are 1, 2, 3, 4 things, it's going to print the first element, comma, the second element, comma, the third element, etc., which you know by now prints them with spaces in between. So literally you can just type this star row. Okay, and what that does is it just prints, each time it's going to print whatever row contains, separated by commas, and you get the exact same output. So there you go. There's easy mode for you if you want to do this specifically. Okay, let's look at example 1 here. Add each element in a 2D list A. So if we want to add all these elements together, then what could we do? Well, simply we need to just process the list, right? Go through and access each element one at a time and add them to a running total. So what we could do is start by setting a running total to 0, right? And then for row in A and for elements in row, what we're going to do is just add that thing to total. So we'll add plus equals lm. Right, so in this case, these are all integers in here, right? So this should work just fine. And then when we're done, we'll just print this. Print the string version of total. And we should now see the sum of the numbers 1 through 9, which is 45. All right, we're going to finish this lesson with looking at how to read a 2D list. That is to take inputs, right, from a user in a grid form of some sort. So how could we do this? Well, first, you kind of need to know how many rows of input to take, right? Or use a sentinel stop value, such as a blank list, right? So, so kind of in general, the best way to do this is to use input.split, right? So, because we know we can type a whole pile of things if we use input.split, and it'll automatically become a list, right? To which we can append that thing to a larger list of inputs. So so you go row by row. We're going to go row by row, and we're going to take input and append that to a larger list. And that's all we're doing here in this example. So taking a 2D list input, and we'll comment this out and finish with this last example. So what we can do is take rows as an input. This is int input rows, and this will give us the number of rows we want to take. We can initialize our list, and we'll set my list to nothing, an empty list, and then for each row in range rows, which is what the user typed, right? What we'll do is just append, right? My list dot append input dot split, right? And so we're just basically adding a row of user input, basically, right? Because this will split itself into a list of the appropriate length, depending on how many things were typed, separated by spaces, and then that will get appended to our list, right? And this will happen rows times, right? Whatever we enter at the beginning. Okay. Now the other way we could do this, which is again always cooler, is using a generator. So taking input with a generator. This is the next level version. So we still need to know these rows. So we'll input this, right, in this case. And this time what we can do is just say my list equals input dot split for x in range rows. So what this is going to do is, well, this is going to happen range rows times, right? For x in range rows, it's going to create an element that consists of input.split, which is a little list of inputs, right? So this is going to do the exact same thing. And then we can print this. Print my list. And you should see, if we comment out this one, that this should do the trick. So we'll type in our rows 2, and now we'll type some stuff in. The cat went to the store. The dog sat on the floor. Right, so there you go. Right, the cat went to the store, and now we have the second one. The dog sat on the floor. Right, so we have a 2D list full of words. Okay, so So this is, in general, how to create and process and read a 2D list. And again, like I said, this is kind of tricky. You're going to have to fight for this one a little bit, guys, but we're going to take our time. We're going to do these assignments here on Replit 1.6 A to D, and be sure to ask lots of questions so you understand how to do this, because this is going to be crucial for what we're doing at the rest of this class. And of course, if you go on to ICS4U. All right, guys, thanks for watching, and we'll see you later.